Okay, so moving to this chapter number 6, electromagnetic induction. Now, itself in the chapter, try to understand. Means what is there in the chapter? It is made up of 3 to 4 words: electro, then magnetic, then induction. Okay, so electro means electric. Okay, and magnetic, magnets. Induction means induction of like appearance. You can say induction means appearance. Okay, means what is going to happen, that by presence of electric and magnetic field, means there is a inclusion of electric field also. Okay, so if there is, like, we can even consider that there is a little bit of presence of electric field or magnetic field, what we are going to observe that something is going to induce due to that, right or not? Okay, and like if the magnetic field is there, if the electric field is there, something will induce, or with respect to that quantity which is going to get induced, electric or magnetic field can be produced over there, right or not? So these two things which we are going to study in this chapter. Now, one of the most important point of this chapter is, this particular topic, like it's related to like all the points of electric field and magnetic field and their appearances in different type of structures. Okay, now one of the most important thing over here is that inclusion of magnetic field. Okay, till now in the, like in first chapter when we were discussing about Gauss law or something like that, what was the use of things? There was one particular term that was coming, that when we consider particular kind of electric field, particular kind of magnetic field, with that electric field, with that magnetic field, there was inclusion of electric field lines, magnetic field lines. Yes or no? Means if I have electric field, I'll tell about the strength of the electric field with respect to electric field lines. More nearer the electric field lines, more will be the strength of electric field. More far the magnetic field lines, more less will be the strength of magnetic field lines. So these were the properties. Second property of magnetic field was what? It will come out from the north pole, enter into the south pole. These are the basic properties of electric fields and magnetic fields over here. Okay, and these basic properties have one biggest important thing, that they are dependent upon electric field lines and magnetic field lines. Right or not? Means we determine, we say about the electricity or we say about the electric field or whatever it is in terms of which kind of lines, which kind of properties, in terms of electric field lines and magnetic field lines. And these lines are going to determine about the intensity of all these fields. Okay. Next thing is that when we got to know that electric field lines are there, electric field is there. For electric field line, when it is passing through some kind of area or something like that, we used to tell about something like electric flux or not. Tell me yes or no. Now one thing is there, I told about something called as electric field energy. Yes or no? I gave one extra topic to you or not? I gave, like, it was equal to half, something like half E square, there was a term. Okay, so you have something like electric field energy. Just check it in that particular first chapter, word or not. So I told that every electric field, whatever electric field you have, for that electric field, what will happen? There will be some kind of energy associated with that field. So similarly, if you have a magnetic field, if you have what? Magnetic field. For that magnetic field, I will have some kind of energy associated with it. Now, if these electric fields are going to move, they will generate what? Flux out of it. Means we need to tell about the flux. What was flux? It tells about how much electric field energy is passing. Okay. So similarly, if I am talking about magnetic flux, what I am talking? Magnetic flux, it will talk about what? It will talk about the how much magnetic field energy is passing through some kind of surface area or something like that. Because if I am talking about magnetic field energy, that means what? What we are actually talking about? We are talking about magnetic field lines. How many numbers of or how much is the total magnetic field lines are going to pass through some kind of surface area. Got it or not? Now look over here. If we consider the area, what is the area? Area is some kind of vector quantity or a scalar quantity. Area is a vector quantity or a scalar quantity. Vector quantity or a scalar quantity. Area is, how many times I will have to tell you that area is a vector quantity. What is the direction of area? It is equal to the, what is the direction of area? Direction of area is normal. Yes or no? Direction of area is given by its normal. So direct area is what? Area is some kind of vector quantity and direction of area is given by normal. Got it or not? Now, next property is what? If we consider the normal or something like that, if we are considering some kind of normal for area or something like that, then based upon that we can define two kinds of area. One area that is called as closed, one area which is called as open. Yes or no? There can be two areas or not? One which is closed, one which is open. Now, example of closed areas are what? A sphere, a spherical shell, cylinders. Okay, closed from up and down. Right or not? But open areas are what? Plain sheet of paper. Right or not? Cylinder, which bases are open, got it or not? So these are example of which kind of areas? Open area. Now remember, if you are solving any kind of numerical, if you are solving any kind of numerical or any kind of physical concept, if you go by closed area for the whole numerical, for everywhere, for each and every point, you need to solve using closed area consideration, got it or not? If you consider for like whole numerical, like there are different parts of numerical, one part, two part, three part. If you are including open in one of the part, then for all of the parts you will have to consider open areas. Got it or not? Yes or no? Now, so let's suppose if we have any kind of surface. So we have considered over here some kind of, this is my what? Some kind of surface over here. Got it or not? In this surface, I selected one smaller region and I wanted to know that what is the area of this region or something like that. To know about this particular region, to know about some kind of particular area of this region or the direction of this region, what I'll have to do? I'll have to first draw the normal. Is I have to draw the normal or not? This normal will tell about what? Direction of surface area. What it will tell? Direction of surface area. Right or not? Yes or no? Now, this direction of surface area, now since we have considered here what kind of area? Infinitesimal area or not? Tell me yes or no? Infinitesimal area or not? So for this infinitesimal area, the direction of surface area is given as what? It is equal to the normal. Got it or not? How to draw the normal? Draw one tangent on this surface area. On this tangent, just draw one perpendicular. This perpendicular will be given as the normal for that surface area. Got it or not? Yes or no? Next thing. So similarly, try to understand if we have such kind of surface, one particular direction of normal, and this is giving the direction of area or area vector, whatever it is. So similarly, I can consider, let's suppose in down of this plane, I can draw one another surface or not. Tell me yes or no. Now look over here. There is a difference in this question. Here it is a open surface. Yes or no. Look over here. But here is it a closed surface or not? Tell me yes or no. Is it a closed surface or not? Yes or no? Why? Because I have just covered this from back side. Right or not? So now, if I have a closed surface, so for this closed region also, can I just tell about something like dA vector? Yes or no? And it has drawn here inside, but actually it should be outside which I am drawing. So here also, if I just draw this normal will show what? Direction of curved surface area. What it will show? Curved surface area. Got it or not? Or yes or no? Now, if some magnetic field lines would have been passing through this particular surface areas, right or not? If magnetic field lines should have been passing through this some kind of surface areas, and if magnetic field lines would have been passing through this kind of surface areas, so then the total flux in this region, the total magnetic flux is given by, this is the sign of magnetic flux. What it is called as? It is called as phi. So this magnetic flux is given as what? It is just like electric flux was what? E dot dA or not? Tell me yes or no? So similarly, magnetic flux is equal to B dot dA for open surface, and it is equal to integral closed loop B dot dA for such kind of closed surfaces. Got it or not? Yes or no? Yes or no? Is that correct? Now, remember that total magnetic flux for any kind of closed surface is how much? Just like previous case, let's suppose if you have a cube, okay? If you have a cube, try to understand. If you have a cube, then let's suppose if the electric field lines were passing like this way, what was the flux? What was the electric flux? Zero or not? For any kind of closed loop, the total electric flux will be how much? Zero. So similarly here also for all of this closed loop, for whole of this closed loop, it will be equal to how much? It will be zero. So phi perfectly for perfectly closed loop is going to be equal to how much? Zero. Right or not? Yes or no? Are you able to get me or not? So if it is a closed loop and the flux is zero, so that means what? Is the flux of this region, try to understand what region I am saying, is the flux of this upper region, means the flux for this region, and the flux for this curved region, that is phi 2. Let's suppose I call this as phi 1, I call this as phi 2. So is phi 1 should be equal to phi 2 or not? Tell me yes or no? Or yes or no? Just like your cube. See, what is happening? The phi over here and the phi towards back side, because here the normal is towards this side, here the normal is towards this side. So one is positive, one is negative, and therefore you are considering it to be C. Look over here. Theta is how much? Here, look over here. In this case, here, try to understand. Here, this is my direction of electric field. This is my normal for this surface. So here theta is how much? 0. But here this is my normal and electric field is towards this side or not. So here theta is how much? 180 degree. Got it or not? Now here, that means what? This dot over here shows what? Dot product. What does it shows? Right or not? So therefore, here also, what used to happen? Flux used to be 0 or not? For this case, because one is 0 degree, one is 180 degree. Right or not? So similarly, also over here, it should be equal to how much? This thing is B dot dA. That means what? If someone asks what is total flux, you can write BA cos theta. Right or not? Yes or no? Remember that. So that means what? For this upper region, for this particular upper region, and for down region, the flux in the upper region, the flux from the outer region or down region, both of the flux should be what? They should be equal. Upper region flux is called as magnetic flux due to upward part, downward part it is called as magnetic flux due to downward part. Got it or not? Yes or no? Both of the flux should be what? Similar in case of closed loop. In case of which kind of loops? Closed loops or closed surfaces. Got it or not? Yes. Okay. Chandru Baba, Chandru, Pori. Uh-huh. Chandru is sad. His proposal was not got accepted at all. Chandru, it's a serious matter. Yes or no? Grave matter. Chandru, पढ़ले यार. Okay. Don't be like me. Do not think me as followers. Okay. Means do not follow me. I was born intelligent, got it or not. That's why I enjoyed my life. You have to work hard. Got it? So do not run behind girls. Run behind physics. Okay, can I move ahead? Do it fast. Okay. So now look over here. This is what it is saying. If you consider for one reason, let's suppose the flux over here is phi 1 for this surface area. For this down surface area, let's suppose the flux is phi 2. Since it is a closed surface area, phi 1 should be equal to how much? Phi 2. Right or not? Both the flux should be what? Similar. Now, one case is there. Now try to understand. Let's suppose if you have some kind of area. Okay, let's suppose if you have a perfect some kind of area over here. Now what is happening is that for this rectangular surface area, the magnetic field is not passing perpendicular to it, but it is making some kind of like try to understand this magnetic field is making some kind of angle theta with respect to the normal. So look over here. I have told now area is denoted by what? Area direction is denoted by its normal. Yes or no? Or yes or no? So therefore, I will draw first normal over here. Right or not? When I have drawn normal, what I observe that this magnetic field is making angle theta over here. How much it is making? Making angle theta. So then what should happen? The flux given by through these kind of surfaces, the magnetic flux, what kind of flux? Phi B I am saying, okay. It should be equal to how much? B into surface area into what? Cos theta. Right or not? One of the NEET question was there, okay. So what was the NEET question? Let's suppose the surface is like this way, okay. For confusing it was given, okay. Surface was like this way, okay. And the magnetic field was given like this way. Got it? What it was saying that this magnetic field with the horizontal is making how much angles? 37 degree. How much it is making? 37 degree. What will be the equation of flux? Tell me. B is it going to be cos 37? No, I have to take the angle with the normal or not. This theta is the angle between what? Magnetic field and normal. Magnetic field and normal. So first I'll have to draw the normal for this. Yes or no? Yes or no? Then we have to calculate this angle for the normal or not. If this is 37, this will be 53 degree or not. What should be phi? Yes, cos 53. Not cos 37 or sin 37. Right or not? Yes or no? You can use sin 37 because that will be angle, but that's not correct. Okay. You use 53 or something like that. Okay. Understood? Is it okay or not? So here theta is nothing but angle between normal of angle between normal of area surface area, okay, and magnetic field lines. Got it or not? Yes or no? Can I move ahead? Written? Yes or no? Okay. So now look over here. We'll define some kind of SI units. Okay. So now flux is equal to what? Magnetic flux is equal to B dot dA. Yes or no? B dot integral B dot ds. Now SI unit of hey, Chandra, look over here. What is the SI unit of B? Tesla? Yes or no? SI unit of SI unit of ds is what? SI unit of surface area is what? Meter square. So what is one of the unit for flux? Tesla. This is magnetic flux. It is equal to Tesla meter square. and this Tesla meter square is actually called as Weber. What it is called as? Weber. So that is why sometimes the SI unit of magnetic field is also called as Weber per meter square, not only Weber. What it is called as? Weber per meter square. Right or not? Are you able to get me or not? Yes or no? Is it okay? Okay. Now give that, like, give the heading CGS unit of magnetic flux. Now look over here. Try to understand. For this particular magnetic flux, can we define some kind of CGS unit or not? This CGS unit has a special name. It is called as Maxwell. What it is called as? Maxwell. Word or not? Are you able to get me or not? It is denoted by capital M into a small x. In NEET 2013, it has asked. Okay. Sometimes it has some kinds of different question. Okay, out of the book. That this is these are the questions some kinds of out of the book. Okay. So it is not out of book. Just it is notations. Okay. Now look over here. When we are considering Maxwell, if I consider CGS unit, so first I'll have to use the CGS unit of magnetic field or not. Now, Tesla is the SI unit. In CCS, it changes to Gauss. In what it changes? Gauss. Now, mention over here that one Tesla is equal to 10 to the power of 4 Gauss. Right or not? Yes or no? So first I'll have to convert Tesla into Gauss or not. So it will become what? 10 to the power of 4 Gauss. Now, meter will change to centimeter or not? Or yes or no? Now, 1 meter is 10 to the power of 2 centimeter. Yes or no? So therefore, if it is meter square, so it will become 10 to the power of 4 centimeter square or not. So therefore, phi in terms of CGS system is what? It is equal to 10 to the power of 8 Gauss per 8 Gauss centimeter square. Got it or not? Are you able to get me or not? This was the actual question. Find the flux in terms of CGS unit of system. Many people have written only 10 to the power of 4. Got it or not? But it will be actually 10 to the power of 8 cos centimeter square. Got it or not? And this is also called as 10 to the power of 8 Maxwell's. What it is called as? 10 to the power of 8 Maxwell. Got it or not? Yes or no? Hey, Ian Martidura. Chandru has broken this bench. Brain has bench has broken Chandru. He have cutted his veins. Chandru, you sell your kidneys to me. Do not cut the veins. Okay. I'll utilize it for buying my iPhone. Right or not? My dream is only one thing. I can't buy iPhone by money. I'll buy the iPhone using kidneys. Right or not? Now let us see whose kidneys it will be. Okay. If Chandru didn't crack NEET, his kidney will be there. Okay. Now look over here. So can you now look over here. Can you define the dimension of this dimension? So I'm just writing the dimensional formula. You have to derive it. It is ml square to the power of minus 2 a to the power of minus 1. It is your work to derive. Right or not? ml square to the power of minus 2 ampere. A is what? Ampere. Ampere inverse. Right or not? Okay. So it's your work to do it. Are you able to get me or not? Okay. Can I move to next point? Hmm? Now look over here. Write one question. So magnetic field is given as B1 I cap plus B2 J cap plus B3 K cap. It is saying that a square sheet of side A of length, you can say of length A, is lying in YZ plane. Where it is lying? It is lying in YZ plane. Find the flux through it. Find the flux through it. Do it fast. What will be answer? Chandru, how come it will be 0, yaar? This is not a closed loop. What I told, rectangular sheet, plane sheet are not an example of closed loop. They are open loops, open kind of surfaces. X, Y, Z. Yes or no? X, Y, Z. Do it fast. Do it. Tell me. It's the answer. You can give it by mouth. Huh? It's the answer. Answer you can give it. It can it be placed like this way. It can't be rotated. It's not possible. Okay. So now look over here. You have some kind of where you have planes. It is in YZ plane. Right or not? Yes or no? Wait fast. Tell me the answer. How to do it? I'll have to take the dot product or not. Tell me yes or no. If it is in YZ plane, where is the direction of normal? Where is the direction of normal? Huh? This is your rectangular seat in YZ plane. Void or not? Okay. So if it is in YZ plane, okay, let me do some drawing. Okay, I have done the drawing. It's enough. Now look over here. So if I draw the normal, this normal will be parallel to x-axis or not? Tell me yes or no. Look over here. Try to understand. See this. I have told about this trick. If your plane is in YZ plane, one normal will be like this way. It will be along the x-axis. That means what? N cap will be equal to y cap or not? Tell me yes or no. If it is lying in xz plane, if the surface is in this region, so the normal will be parallel to y-axis or not? Tell me yes or no. Are you able to get me or not? Now, magnetic field is given as B1 I cap plus B2 J cap something something something. Flux will be what? B dot ds, yes or no? Or B dot S vector. Now look over here. B is what? B1 I cap plus B2 J cap plus B3 K cap. Now it will be what? Dot product with what? S vector. S vector. What is the direction of S vector? Towards the I axis. Yes or no? Or X axis. Now surface area of a square is what? A square. It is A square or not? Tell me yes or no. So A square I cap it will be there or not? Tell me yes or no. Or yes or no. Now, so therefore, what will be your value of flux? It will be equal to how much? B1 into A square. So how much is the flux value? B1 into A square Tesla meter square. Got it or not? Yes or no? Is I'm okay or not? Clear? If this plane would have been given in XZ plane, so J cap would have been given. Normal will be equal to what? J cap at that time. Understood? Okay. Can I move ahead? Solve the second question. What is saying? If you have a long solenoid of radius how much? 4 centimeter. Length is given for it. Length is given how much? 400 centimeter. Means solenoid length is given. What is given? Solenoid length, and it is carrying how much current? 3 ampere. What it is saying? The total number of turns in is how much? 100. Assuming that it is ideal solenoid, and the pass flux, what do you have to calculate? You have to calculate the flux which is passing through the circular surface having center of axis of solenoid of radius how much? 3 centimeter, and is perpendicular to the axis of solenoid. Okay, first you have to calculate inside, and then you have to calculate at the end of the solenoid. Okay, so what it is actually saying, let's suppose if you have a solenoid like this way. Okay, hey Chandro, look over here. Do it fast, 2 minutes. Without doing, I'll not say the answers now. Do it. Okay. So let us consider you have some kind of solenoid, right or not? Now, this is my solenoid over here. Okay. Now, it has what it is saying. So, the long solenoid of radius is how much? 4 centimeter. Okay, so radius of the solenoid is given. So, let us consider this is my radius. So, the radius of the solenoid is given and this radius is equal to how much? 4 centimeter. Length of the solenoid is also given, that is equal to 100. So, can I say it is 4 meter? Is the length of the solenoid is equal to 4 meters or not? So, length of solenoid is how much? 4 meter. Current carrying it is, let's suppose it is rotating in anti-clockwise initially, current it is having how much? 3 amperes. Now what it is saying, if you consider one circular surface area, so it is saying if you consider in it one circular some kind of surface area, got it or not, whose radius is given as, means the radius of this circular path is how much? 3 centimeter. You have to calculate what? Flux passing through this circular area. Dhanush, wake up. So you have to calculate what? Flux passing through this circular surface area or circular surface of radius how much? 3 centimeter, which is perpendicular to the axis of solenoid. Okay. Now axis of solenoid means what? Passing through the center. This will be my axis of solenoid. This is my axis of solenoid. Now look over there. That circular surface area is also perpendicular to axis of solenoid. Right or not? Okay. What we'll have to calculate for to calculate the magnetic flux? First, should we know the magnetic field inside the solenoid or not? Or yes or no? So what is that formula? Magnetic flux inside the solenoid or magnetic field. First of all, you need to know magnetic field, which is equal to what? Mu naught N I. Mu naught N I divided by 2 pi R. 2 pi R or what? Huh? What was the what this n is? This is, I told one thing. If you use capital N, it is number of turns, and if you use a small n, it is number of turns per unit length. Right or not? So here this magnetic field should be divided by length or not? Which is, this should be divided by what? Length of the solenoid, so as to calculate what? Total magnetic flux inside, total magnetic field inside the solenoid. Got it or not? Or yes or no? Is it okay or not? So now look over here. Mu naught. What is the value of n? See, the total number of turns is 400. So 400. Length is how much? Length is how much? 4 into current I. Right or not? So therefore, B can be given as 100. It is okay. So 100. So that is how much? 25 mu naught I. So magnetic field is 25 mu naught I Tesla. Right or not? Yes or no? Now look over here. If you look over here for this R, is this R, what is the direction of this circular surface? Towards this side or not? Tell me yes or no. And magnetic field for the solenoid will be like this way or not? So is the magnetic field lines and the normal of the circular surface is making 0 degree with each other? Yes or no? So theta over here is how much? 0. And magnetic flux would be what? B into ds into what? Cos 0 degree. Now, what is the surface area of this circular region? Pi r square. This is equal to pi r square or not for this region? So B, which is 25 mu naught I into pi. R is how much? 3. So 3s square into cos 0 degree. Got it or not? It is 3 centimeters. So 10 to the power of minus 4 will come over here. Got it or not? Can you do it? So if you solve it, it will come as 0.27, okay, into 10 to the power of minus 6 Webers it will come, okay, or Tesla meter square. Point or not? Okay. This is the first question answer. Means first point. There is another point. What it is asking? It is asking the magnetic field at the end of the solenoid. Rakshita, what is the formula for magnetic field at the end of the solenoid? Mm-hmm. It is HM. How much it is? Magnetic field at the end of the solenoid. Huh? This test you guys gave it now. Then if you have magnetic field B inside the solenoid, so at the end it is half of it. It is equal to half mu naught Ni by L. So therefore, the phi at end is going to be this half of this phi. Right or not? Yes or no? Can I move ahead? Done or not? Question number 2. Do this. What it is saying? A long straight wire carrying current I, means you have some kind of long straight wire which is carrying how much current? Current I it is carrying, and a square conducting wire of loop side L. So you have some kind of a square over here, okay, of length how much? L, while you have some kind of current carrying wire, okay, at a distance A from current wire as shown in the figure, okay. Both the current wire and the loop are in plane of paper, means they are in the plane of paper. What is asking? Find the magnetic flux. What it is asking? Find the magnetic flux of current wire passing through the loop. So you have to calculate magnetic flux of this particular wire. So Chandru, due to this current, what will develop in the square loop so that we are asking magnetic flux? Due to this current, something will develop over here or not? Look over here. Sit down. Sit down. You will not be able to answer. So look over here. Due to this current, some magnetic field will be developed in this loop or not? Tell me yes or no. Or yes or no. Because for every current carrying loop we know that it has circular concentric magnetic field lines, got it or not? So therefore these magnetic field lines are passing through this surface or not? Tell me yes or no. If these magnetic field lines are passing through this surface, definitely it will create some magnetic flux in this or not. So you have to calculate that magnetic flux over here, got it or not? So can you calculate it? Do it fast. Do it. Hey. Harshita, how to solve this problem? Logic. Any kind of a square plate, any kind of a thing, how do you calculate the magnetic flux, electric flux? Was it easy to calculate? Or did you need to first consider the smaller element? Yes or no? So now, so first, what I will do, this is my square plate. In that square plate, I will select one smaller element. Okay, and this smaller element, consider, let's suppose if it is has length, how much? This smaller element has length dx over here. How much is length? Dx. What is the length of this smaller element? Dx. While the this breadth part is how much? It is equal to similar to the length of the square loop. Right or not? Let us consider that this smaller element is located at distance x from the end of the wire. Got it or not? Or yes or no? Now it is a infinite, like both the ends of this wire are infinite or not? Tell me yes or no? So B will be equal to what? Mu naught by 4 pi I divided by distance r. Now, is this a square loop? Means first I'll calculate for a smaller element, right or not? So where is this smaller element located at distance x or not? Tell me yes or no. So at distance x into what? Sine theta 1 plus sine theta 2. Now, what is the value of theta 1? What is the value of theta 1? 90, theta 2 90. So therefore it is going to be how much? Mu naught by 2 pi I by x at this square loop or not? So did you got your magnetic field at this square loop? Means in this rectangular smaller strip, yes or no? Now if you integrate this, if you integrate over the here, so what you will get? You will get the magnetic field flux for the whole region or not? Tell me yes or no. So now look over it. What is the formula for magnetic flux? Integral B dot ds. Yes or no? Flux is equal to what? Integral B dot ds. So it is going to be what? Integral B dot. Now look over here. ds is equal to what? Length into breadth. Right or not? Length is similar. It is equal to length L. Breadth is, but it is different. It is equal to what? Dx. So length L into dx. Now look over here. Integral B value is what? Mu naught by 2 pi I L by x into dx. Now look over here. From where to where we have to calculate the magnetic field? From some region, yes or no? In this some smaller region we have to calculate or not? From where to where? From length A to this length is going to be what? A plus L or not? Tell me yes or no? Or yes or no? So this limit should be what? A to A plus L. What I get as a relation mu naught I L by 2 pi. Now integral 1 by x dx is what? Log x. Yes or no? Yes, is it log x or not? Yes, now log x from where to where? A to A plus L. Right or not? Yes. So what is the value of flux? Mu naught by 2 pi. It is equal to mu naught by 2 pi IL into what? Log A plus L divided by A. Right or not? Yes or no? Now one thing is there, try to understand. If the current is upwards, what will be the direction of magnetic field? It will be like anti-clockwise or not? Tell me yes or no? Or yes or no? Thumb upwards, rotate it. So what it is rotating? Anti-clockwise? Or yes or no? But the direction of normal for the surface area, it will be towards upwards this side or not? Tell me yes or no? Magnetic field is going inside, and the particular normal is what? Upside. Look over here. This is my current carrying loop. For this is my square loop. Okay, means it is kind of this way. Okay, this is my square loop. Right or not? So for this, what will be the direction of magnetic field? It will be like this way. Some kind of, means try to imagine it. Right or not? So look over here. If it is like this kind of a square loop, so what? How it is passing? It is passing like this way or not? Tell me yes or no. This is my current carrying loop. This is my square loop. Right or not? So magnetic field is like this way. It is passing, but the normal is towards this side or not? So what is the angle between the magnetic field and the total normal? Is it 180 degrees? Yes or no? So here one term will come or not? Cos 180. So cos 180 is what? Negative. So all of these terms will be what? Negative. So flux is what? A negative of V naught by 2 pi IL dot log A plus L divided by A. Got it or not? Easy peasy? Yes or no? Got it or not? Any kind of doubt?